In this video, we're going to talk about how we can use the complete the square method to convert a quadratic function from standard form to vertex form. So we're going to do a little review first, and we have to be pretty confident with some perfect squares, because that's going to help us in this complete the square method. And so let's just do a little bit of review here first. When we've got a binomial that's squared, if I were to write this out, this is the same as x plus 4 times x plus 4. And if I multiply those two binomials, I would end up with x squared plus 8x plus 16. If I do the same thing with x minus 4 squared, well, that ends up looking very similar. They both have a c value of 16, and that's because 4 squared is 16, negative 4 squared is 16. But the b value is different. Here, we get an 8 as our b value, and 4 plus 4 is 8. Over here, we have a negative 8, and that's because negative 4 plus negative 4 is 8. So hopefully, as we're working through this complete the square method, we're able to see how the value in the factor here matches with what we've got in our standard form equation. Okay. If we were to go the other way, well, we want to factor these standard form equations. And so typically we can think of, all right, well, this number here has to be the square root of my c value, because c is a perfect square, and square root of 25 is 5. But since my b value is a positive 10, this must be a positive 5. Okay, so again, going back here, we notice that 2 times 4 gives us 8, and then 4 squared gives us 16. And when we did 2 times negative 4, we got negative 8. And when we did negative 4 squared, we got 16. So down here, square root of 25 is 5. Half of 10 is 5 there. Okay. So this other example here, now we've got an example with that is the same example we just did right here. So let me quick change that. Okay, that's better. So my c value here in my other example is 9. Square root of 9 is 3. And then just to double check, if I take half of my b value, negative 6, that gives me a negative 3. So that means I have x minus 3 squared. Okay, so all of these are examples of perfect square trinomials because we end up with the same factor twice. Okay, and that only works if it's a trinomial where the c value is a positive perfect square. Okay, so we're going to use this idea here with these examples to help us with completing the square. So if I were to have this b value here, what would I want for my c value to complete the square? Well, I know I'm trying to get something that looks like this. So I have to figure out what is this factor that I want here that gives me a 14 as my b value. Well, from our previous examples, I know that I just have to divide my b value by 2. That gives me a positive 7. So then if this is x plus 7 squared, I have to take 7 times 7. And that gives me a c value of 49. Okay. Next example, make sure to pause this. Give it a try yourself before we take a look. So again, I know that I'm looking for something that fits in here. Divide my b value by 2, and I get a negative 6. So negative 6 squared is positive 36, and that is my c value. Okay, so now let's put this all together with a full equation here. So let's say we're given standard form here, and we need to convert it to vertex form. So looking at just my first two terms here, like we did with the last two examples, if I had x squared plus 6x, well, 6 divided by 2 is a positive 3. Okay, so that would give me x plus 3 squared. But 3 squared is not negative 11. Right? So that negative 11 doesn't allow us to rewrite my equation using, this this completing the square method here. Okay, because negative 11 is not a perfect square, it doesn't fit. So I kind of want to get rid of that negative 11, and then I'll add it back in later. So essentially what we're doing is I'm coming back to this example here and saying, okay, based on my b value, what is this factor going to look like here, so I can get vertex form? That's going to tell me what my c value should be. So now coming back here, if I just kind of reset here, what I'm trying to get to is vertex form here. So it's going to look something like that. So I have to complete the square to figure out what goes in here, but I might have some other terms that go with it. Okay, so I'm looking to complete the square here, but that minus 11 doesn't really work with what we're doing here. So I'm essentially just going to kind of cross it out here and move it off to the side. I'm going to pretend my equation is just x squared plus 6x. Okay, so I divide 6 by 3, not by 3, divided by 2. So I cut 6 in half and I get 3. And now I take 3 squared and I get 9. So how we find this c value that we really need to have to complete the square, we have to take our b value, we have to divide it by 2. So we took 6 divided by 2 to get 3. And then we have to take that value and square it. So that's kind of your go-to here when we're converting from standard to vertex form. B divided by 2 squared. Okay? So my next line is going to include y equals x plus 3 quantity squared. But in order for that to happen, I need to have plus 9 as part of my trinomial at the beginning. Well, I can't just take an equation and add 9. That's going to give me an entirely different equation. So I need to balance that out. If I add 9 to the right side, I need to either add 9 to the left side, or I would rather completely work with the right side of my equation and not even mess around with the left side. So if I add 9, I also have to subtract 9, right? Because 9 minus 9 is 0. So if I add 9, but I also subtract 9, I'm not changing what the equation tells me. I'm just changing what some of the numbers are inside. And so if I take the x squared plus 6x plus the 9 that I added in there to help me complete the square, well, then what's in the parentheses here can be rewritten as this x plus 3 squared. And now the stuff that I have on the outside here, I can combine those, that becomes a minus 20, and then I just add that to the end of my equation here, and that is essentially my vertex form here. So now I have y equals x plus 3 quantity squared minus 20, and that tells me that the vertex with this equation is negative 3 comma negative 20. Okay? All right, let's look at one more example. So make sure to pause, do as much as you can on your own first, then we'll come back. So remember, I'm trying to get a vertex form here. All right. Now to figure out what goes in my parentheses down here, that's where I divide by 2, and I get -6. Well, in order to find the b value that works, recall we're doing b divided by 2 and then squaring it. So I do b divided by 2, I get -6, and -6 squared is not 30. So once again, I'm just going to take this 30, move it over there. And now when I take -6, square it, I get plus 36. Okay, so when I add that 36 as my c value, now that equation, that trinomial in the parentheses, I can rewrite as x minus 6 squared so that it becomes vertex form. But I still have that 30 over there. And remember, I just added 36 to my equation, so I have to balance that out, and so I also have to subtract 36. And so I'm going to combine that with the initial c value that I was given in the equation. And so -36 plus 30 is going to give me -6. So then if we're asked for the vertex, we have a +6 from inside our parentheses there, because it has to be opposite. And then the -6 at the end tells me the y value of my vertex.